Good afternoon. I try to be quick. My name is Tilmann Zäschke. I'm from ETH Zürich, and I'm going to talk about SCION. I'm here together with Adrian Perrick and François Wirtz. So if you have any questions about SCION, you can also talk to these two over there who raised their hands. No. Just a question up front. Who is using SCION already? Do we have some people? Very nice. Who knows what SCION is? Maybe, oh, okay. Well, anyway, yeah. The plan is, what's that? Oh, okay. That's the next slide. Okay, so I'm going to start with the SCION recap a bit, discussing what it is, and then the current state of adoption, various news, and finally the SCION day, or SCION days, the upcoming months. So SCION, it's a protocol for secure path-aware inter-domain routing. And one of the main features it has is trust sovereignty. So trust is totally self-governed. There's no reliance on third-party CAs. Also, all ISs you communicate with are authenticated with standard certificates. Another main feature of SCION is it's path-based, path-aware. And in that case, it means that endpoints can actually select the path through the various ASs to the endpoint. And to aid path selection, they get metadata. So metadata can be latency estimates, bandwidth capacities, but also geolocation. That allows, for example, then geofencing, so you can make sure that your route stays within a certain jurisdiction, for example, if that's useful. And also prevents various attacks, like there is just no such thing as route hijacking, for example. SCION is also inherently a multipath protocol. That's useful, for example, for end hosts. When they get paths to a certain destination, they usually get a larger number of paths. And if one of those paths fails, they can just quickly switch over to another path in a few milliseconds. But end hosts can also just simply use multiple paths in parallel, for example, to optimize for bandwidth or redundancy. So how does SCION work? So I have to skip over a lot of details here, but there are some core concepts. One is the isolation domain. So an isolation domain is like a group of ASs that collaborate together and want to share trust. So they have like a common trust root. So an ISD has its own like certificate authority, if you will. So typically you can imagine an ISD or an isolation domain to be like a country, but it could also be just several companies, organizations that want to collaborate and share their own trust. There's also the concepts of public and private isolation domains. Public isolation domains are typically ones that participate in the global SCION network. So they communicate with other ISDs and provide transit for other ISDs. Whereas a private ISD is just self-enclosed, it doesn't communicate with anyone. It's not routable inside or outside, so it's really a private network. But it can still span countries or even continents, if you will, so they can be very large. Another core concept is the strong separation of control plane and data plane. So on the control plane, we have the path discovery. And paths in SCION have the granularity of border router interfaces. So that means if you look at the path, for all ASs that it passes through, it has the ingress border router with interface and the egress border router with interface. And to discover the path, there is a concept that we call beaconing. So in regular intervals, every AS sends out these beacon packets to all its neighbors. And the beacon packets contain the ISD itself and the egress border router. And the neighbors, when they receive such a beacon, they attach their own ISD number and their own border routers to that, forward it to their own neighbors. So over time, these beacons get longer and longer, and they form paths. And if you receive such a beacon, you essentially have a path back to whoever originated that beacon. And these beacons can be stored locally in path servers in every AS for the end hosts to use them. Also, this whole process is authenticated with PKI, so it's impossible to forge paths. There can be no faulty path or looped path or something. Yeah. On the data plane, then, if a client wants to connect to somewhere, they just ask in the local AS for path from the local path server, attach it to a packet, send the packet to the first border router, and the border router then forwards it following whatever the path in the packet says. The advantage here is that border routers don't need to maintain a lot of state, so they have some certificates, but other than that, they don't need a global routing table or anything like that. Yeah, so let's assume you want to deploy SCION in your AS. The good news is you don't really have to change anything. You can just add SCION in addition to whatever you have to your normal internet routing. So what you have is, for example, you have to add border routers just to be able to peer with other SCION-enabled ASs. And you have to add control services, and control services are basically a beacon service that does the beaconing, this path discovery, path service that hands out paths to end hosts and all end user devices, and a certificate service that just caches certificates and manages the PKI infrastructure. And if end hosts want to use SCION, it's usually per application. So an application can be SCION enabled, so it can choose its own path depending on what the application actually needs, whether it's latency or bandwidth, for example. If your applications don't support SCION, which is also obviously very common, then you can use something that's called a SCION gateway. That's like a NAT, or it's like a NAT or proxy. So it takes IP traffic on one side and inserts it into the SCION network and adding a path for you. Okay, that's actually an older. I'm going to skip that one. So for real-world deployments, there is, for example, you may have heard of the secure Swiss financial network. That's actually the Swiss interbanking network with about 300 financial institutions. So they use SCION internally for this network. It's governed by the Swiss National Bank and SIX, and some of the reasons why they use SCION, or what the advantages of SCION here are, is this trust sovereignty, but also the ability to authenticate all ASs they communicate with. Then SCION works across ISPs, so you are not dependent on using one ISP. Then it allows geofencing, so you can cryptographically ensure that your packets actually stay in a jurisdiction. And also, you can do the performance-based routing by always finding the shortest path or the fastest path, and you have the fast failover in case of things going wrong. Other deployments are the SCION education network, Sierra, that it's basically universities all over the world that have together one network. I think we have universities in North America, South America, in Europe, and in Asia. So that's a public network, a public isolation domain, and it's connected to the public global network. We have the secure FDOS payment network. Actually, that's wrong. It does not plan to use it, so it is using SCION for cashless payments already in Switzerland. Then we have the healthcare network that connects Swiss hospitals and doctors. And also there is a Swiss utility network that's under construction. But according to the Association of Swiss Electricity Companies, they actually have it, have written that it's mandatory for all participants to actually join this SCION-based SS by 2030, I believe. Yeah, so I've mentioned the public network, just to give you an idea how big it currently is. In the registry, we have 240 ASs. But in the global public network, only about 100 of those are reachable, which makes sense because there are lots of private ISDs, private networks, which are not meant to be reachable. And what I do every now and then from my office desk, basically, I try to trace route to all available ASs, all reachable ASs on all available paths. And when I do that, I get the numbers in the table below. So first row is the path per destination. So if I order all ASs by how many paths I find are available and actually work to each destination, I get a median of 200 paths per destination, with a maximum of almost 6,000 paths to one of those destinations. For the fastest path to every destination, the length of the path is about 4 hops, so that means 4 ASs, and the maximum is 7. So within 7 hops, I can reach every destination at the moment. And for the round trip times, I get on the fastest path to every destination a median of 4.1 milliseconds. I think that suggests that more than half of the ASs are actually in Switzerland or close to Switzerland. And the maximum is 360 milliseconds, and I think that was AS in South Korea maintained by or owned by Samsung. That's the SCION ecosystem. It's also, somehow this slide shouldn't actually be here anymore. We have a lot of people that we collaborate with, but this list is very incomplete. So talking about news, we have been working a lot to get SCION standardized with the IETF, Internet Engineering Task Force, on the independent submission stream. So we have several drafts. The data plane and control draft are actually very progressed. So they're currently with the RFC editor. So it's we only expect editorial changes at this point. So they are kind of done. On other news, we have worked a lot in the past 2 years on client libraries. So we now have proper client libraries for Go language, for Rust, for C, for Java. Actually, I'm the maintainer of the Java implementation. So if you have questions about Java, then please come to me. We also have a Chromium browser plugin. And kind of 2 things that have changed in the past 2 years in the direction of development is that these SCION enclosed libraries are now standalone. So in the past, you actually needed a SCION installation with several daemons on your machine or your device. So that's not needed anymore. And the other is that we are getting more and more native SCION enclosed apps. Something I also want to mention here, that we have several companies that announced, well, actually not announced, so it's not public, that by the end of 2006 or before the end of 2006, they will publish SCION end-host enabled apps. So we kind of expect to have probably 100,000 or more native SCION users by the end of 2026. And for the reference implementation, I also haven't explained that SCION we have a reference implementation which is maintained by the SCION Association, which is a non-profit organization. But there are also other providers such as Anapaya, for example, that have a commercial implementation. But for the reference implementation, the latest release was 2 weeks ago, and I think one of the biggest features in there was that we finally have support for NAT. So overcoming a NAT was in the past a bit difficult. And finally the events. We have in Netherlands, if you happen to be in Amsterdam in May, we have the SCION Benelux edition on May 19th. In Zurich, we have in June a hackathon. And also in Zurich, we have in October the annual Swiss SCION Day. And you're very welcome to join us there. And that's already it. There's a lot of information out there. from different resources. If you go to the SCION Association website, so if you're interested in using SCION, then you can go to the SCION Association website, and there is also a whole list of all providers, ISPs, IXPs, and so on, and software companies that offer SCION. And that's already it. Thank you.
Thank you, Tilmann. Thank you very much. Any questions?
Do you plan to have an SCION-enabled OS? For example, I don't know, iOS, Android, or support for Windows, macOS, Linux? Not the idea at all.
Well, that would be very nice to have, but it's also very hard to achieve. So in the future, probably, I think. Yeah. Or do you guys agree? Yeah.
Another question? Everyone is urging for the break. Okay, then, thank you very much, Tilmann.